And well, what it was supposed to do is this DC motor was controlled by a potentiometer, which spun the auger inside and pushed out the plastic after it melted, but some trial and error, the plastic got too hot and caught on fire. So I can't cover it now.
Again with fire. Can you back up? Like, what prompted you to think of this? Like, because I don't, or especially our 8th graders don't really know what you're talking about.
Well, we have a 3D printer right now, and so like it's a big thing that everyone wants to use, and there's a lot of things that can happen where like if you misprint something that's just a big hunk of wasted plastic. And I thought like there should be a way to reuse it instead of just throwing it away. So like I use like a coffee grinder and you grind up the plastic and then you put the bits in here. And the auger turns by the DC motor and it's supposed to come out here, but it got too hot and caught on fire. So like these little bits, these pieces is what I use to put in here, and normally the pieces were like this. So like these were all like broken parts that nobody needed. But I have the actual motor that would work with the Arduino. And so that's how the Arduino controls the motor. And then there's a speed thing right here. You can change the speed of the motor.
Could you turn that around so people can see like what's supposed to come out the end there?
There's a hole at the end here, and so the auger turns the plastic to move through the tube to come out here. And you have to have like a specific diameter of it, so I had to measure the filament itself and drill the hole there.
What chops? Because the auger is just going to move it out, right?
Yeah, I have a coffee grinder that I put the plastic inside of.
So your premise is to like re-liquefy the plastic and just push it out that small hole, and then it would
And make
cool into
it
a small
filament
bead.
again.
Okay.
Yeah.
So you're changing that form back into a usable form for the printer. Okay.
And I was, maybe you already talked about this, but at one point you were talking about a temperature sensor. Did you mention that at all?
Yeah, well I had a temperature sensor. For the original thing was I had a pot and it was this metal piece was in there and it was like a double boiler effect, so there's oil. But the pot started leaking and so the oil was hitting the burner, but there was a temperature sensor that detected the temperature and it was hooked up to the hot plate, so then when the Arduino read a certain like value, then it would shut off. And then when it got to a certain value, it would turn back on to detect the temperature.
I don't think we have time today, so we're not going to do it, but before we're done here, we're next week we'll probably do it. We'll take it down in the chemistry lab. We have this, it's called a hood. Do you have one of those at junior high?
No.
And so it's an enclosed box that has an exhaust fan that will suck any fumes or smoke or whatever outside. So we'll try it and see if we can see the liquid plastic coming out in a safe environment. She was testing it last hour, and the plastic, rather than melting, started burning. It's definitely started smoking. So we're not going to try it here in class. Does anyone else have any questions for this project?
Approximately how long did it take you to like figure out how you're going to build this? Because it seems like an original idea.
Well, I saw stuff like there's like the actual MakerBot has its own like filament extruder kind of thing, but it's like $700. So I thought of making one myself that's not going to be that much, so it's like cost effective. So.
Did you look into the temperature? Like, what's your target temperature? At what point does that plastic melt?
It's 175.
Celsius?
No, degrees. So it's like 175. Yeah.
Tomorrow.